As we get into day 4 of science, how do toasters work, we don't have any new vocabulary words, but I did want to take this opportunity to review our prior vocabulary words. Okay, and so the first one that we had was circuit. And we said that a circuit was a loop or a path along which electric current flows. So it's going to flow, and it's going to flow in the same direction, and as long as there's nothing to interrupt it, it's going to keep making that circular pattern, and it's going to continue to flow. Electric current. Electric current is the flow of electricity, so think of it like a river. Okay, and in a river, the water flows. Okay, so the circuit is the complete path, and the current is the electricity flowing through the circuit. The third word that we had on the first day was switch. And a switch is a part of a circuit that starts or stops the flow of electric current. So if you have your current flowing through the switch, and the switch is a brake that may turn that off, and if we take the brake away, then that allows the current to continue forward. And the next word that we had is conductor. A conductor, something that allows electric current to flow easily. So we talked about a couple examples. The metal gold or copper are two examples of conductors because they allow electricity to pass through freely. Okay, but think of it as maybe a hill, and the hill has snow on it, and when there's snow on it, it allows the skier, and I'm not much of a drawer here, so it allows the skier or the sledder to travel more easily. Okay, so it's a conductor, easy travel for electricity. Whereas a resistor is the opposite. Okay, well, not quite the opposite. It doesn't stop it, but it makes it more difficult. Okay, so for a resistor, things like plastic, rubber. Okay, instead of going down the hill, we are going up the hill. And if you've ever tried to push anything up a hill, you know that it is much more difficult to push it up the hill than it is to push it or let it go down the hill. So the resistor, things that limit the flow of electricity. We also had the word filaments, wires that heat up or glow when they conduct electricity. Inside the toaster, so this square will represent, or this rectangle will represent our toaster, and it's got the lever on the side. Okay, but inside the toaster we have those wires, and they glow and get hot. That wire, those wires are the filaments that heat the bread and turn it into toast. And the last word that we had, radiate. Radiate, to send out energy in waves or rays. And so a great example is sunlight. Okay, the sun radiates its energy, and eventually that radiated energy reaches Earth, where we can feel the warmth of the sun through the radiated energy. Let's push that up a little bit. Okay, so there is the warmth of the sun reaching the Earth, and we'll even draw the moon out here orbiting the Earth. Okay, so we know that's the Earth traveling around the sun. The moon is traveling around the Earth, and the sun's energy is radiating onto both. Okay, and giving them both heat energy. Okay, and as we read today, I want us to continue thinking about how information is being relayed to us. Is it through cause and effect, problem solution, compare and contrast, or sequence? Toasters aren't the only appliances that turn electrical energy into heat energy. Electric stoves, electric blankets, irons, and even some cars convert electrical energy into heat energy. All of these inventions use filament resistors that can withstand very high temperatures. But sometimes the materials around the filaments cannot. For example, toast left in the toaster too long can turn black or even catch on fire. That's why you should never leave your toaster unattended while you're making toast. And so let's start thinking about these four types of methods of communication in writing. Okay, and is there any of them, are there any there that we can just say, you know what, it can't be this one? So maybe we could eliminate one right off the bat. And the one that I'm going to eliminate is sequence. There's nothing in there that is in sequence order. Okay, so they're not telling us sequence, or they're not communicating through sequence. Another one that I would like to eliminate is this idea of comparing and contrasting, because even though it talks about they're not the only appliances and then it lists several other appliances, they're not talking about a difference or a contrast. Okay, they're stating all similarities that they have. They all convert energy, electrical energy, into heat energy. So it's not a compare and contrast. Is it a cause and effect? Well, there is some cause and effect in here. Okay. For example, toast left in the toaster too long can turn black and catch on fire, and even catch on fire. So we could say the cause being leaving the toast in too long, and the result being that it would catch on fire. But that's not the main means of teaching or instruction that this passage is giving us. So I think I would also eliminate cause and effect. And so we're kind of left with that problem solution. And the problem being stated kind of right up here. You know, how do the toasters work? And so what do we find out that will help us answer that problem? And the problem is answered in the fact that they're turning electrical energy into heat energy. That's how the toasters work. Other objects, other items use the same method. They turn electrical energy into heat energy. But it's still answering this problem of how do toasters work. They use filament resistors that can withstand high temperatures, and we've learned about how those resistors, the electrical energy is turned into heat energy. And then they bring in this little bit of cause and effect here. If we overdo it, okay, you've got to be careful. If you have too much energy, things can catch on fire, but that is not the main way that this passage is teaching us the information it wants us to learn. So, problem, solution. Okay, so question A. A hairdryer works similarly to a toaster. Look at the diagram of the hairdryer. Where do you think the filaments are? Draw them below. So if you would kind of draw where you think the filaments belong, and maybe put a couple arrows going to them even if you need to make it a little clearer, or just put arrows in the section of the hairdryer where you think the filaments would go. And then we'll talk about that in just a moment. Okay, if you've ever seen a hairdryer, used a hairdryer, this might be a little easier for those of us who have some experience in seeing a hairdryer or using a hairdryer. But go ahead and do your best there. Remember, this part right here, that's the fan that is forcing the air out the other end of the hairdryer. This is the end that you would that would go to your hair. Okay. And then question B. Today, some toasters do more than just toast bread. One toaster can print messages from your computer onto your toast. Another toasts pictures of cartoon characters on the bread. If you could invent a new kind of toaster, what would it do? Describe it below. And again, if you need more space, I really don't know that 2 lines is enough for that. For some it may be, but if you need a little bit more space, go ahead and use the back of your sheet for that. If you would like to take a few moments and after you've answered the question and maybe draw, if you're toaster does something to the bread. You can draw that on the back, what a piece of bread might look like coming out of your toaster. Please go ahead and do that. We'll give you about 5 minutes to work on this part of the lesson.